about a topic in graph theory. So this is a textbook I'm putting together. So with the use of AI tools. So chapter 1, basic terminology, maximum edges in a sample graph. So this is the result with in a simple graph with n vertices, the maximum possible number of edges is n times n minus 1, all of that over 2. So why is that? So as this chapter says, this chapter builds up to that formula. Firstly, definition of a simple graph. So let's say we know that. So taking that into account, let's count the number of the maximum number of edges in a simple graph. So basically, when you have a simple graph with no double edges between vertices, basically a complete graph. So what is the number of edges there? Well, the argument that we can use for that proof is basically that an edge is basically identified as an unordered pair of distinct vertices, but it cannot be used twice. So if it's ordered, it would be double counted, which we don't want. So we do step 1, which is count ordered pairs. You pick a vertex, any of n vertices are all the choices, and then check a second vertex from the first, then it's n minus 1 choices if the number of vertices was n. And then that gives n times n minus 1 ways to pick an ordered pair if you start with a concrete vertex. And then you can remove the ordering by recognizing that we counted all of the edges twice because we took them as ordered. So each edge as a set of u and v, two vertices distinct from each other, has been counted twice in this process. No loops, by the way, of course. And so u and v and u are seen as same, these ordered pairs. But it's undirected, a simple one. So we only look at it as a set, not a sequence. So we divide that number from before by 2, and that's how we get there. So and then we can then we have step 3, basically connect to edges. So every edge in a simple graph corresponds to exactly one unordered pair of distinct vertices. Yes, and every unordered pair can host at most one edge. No multi-edges. And so no self loops, which is a thing that we just mentioned a moment ago. And so the edge set E is a subset of the set of all unordered pairs. All right. And okay, so now let's conclude. We kind of already got to the conclusion, but there are some more steps that don't seem that necessary. That the number of edges is bounded above by n times n minus 1 over 2, which is already what we found. So if we include every possible unordered pair as an edge, we get the complete graph K sub n, which has exactly this amount of edges because it's the same definition. The max number of edges in a simple graph where there's no double edges, no loops. That's the complete graph on that number of vertices. All right, so that's what we get. This number of edges, maximum number of edges in a simple graph.